Hi, my name is Emily Valentine, and I am with Dr. Maria Wheeler, who is currently a biology instructor at the University of Pittsburgh and a conservation education specialist at the Pittsburgh Zoo and PPG Aquarium. She has very generously given us her time to discuss her ongoing research with golden eagles. So, Dr. Wheeler, could you give us an overview of your research?
Yeah, so the project that I've been working on, it was my dissertation research. So I did that while I was at Canary University, and a little of the data analysis is spilling into, I guess, present day. Basically, my research wanted to look at overall the impact of conservation translocations. So golden eagles, they have a really interesting reintroduction or translocation history. So if you look at golden eagles in North America, they have a pretty wide distribution in the western part of the country, or the continent, I guess. But then over in the eastern part of the continent, there's a much smaller population. And when I began my research, it wasn't really known if there were, how many of them there were, if they were genetically distinct from their western counterparts. So kind of when I came on board, my project was just going to look at whether or not golden eagles in the eastern part of North America were genetically distinct from birds in the west. But then, as I started getting more involved in my project, we realized that golden eagles had this really interesting background where a lot of birds had been translocated from the western part of the continent over into the east. And it really wasn't known whether or not that had any impact on eastern birds, because we didn't know if they made it into the breeding population. And since we didn't even know what the breeding population in the east, what the size was, that could have had some different impacts on their genetics. And part of the reason we were so interested in what the genetic population structure was is that at the time, the migratory corridor for golden eagles was right along areas that were really of interest to wind developers. And of course, all of us are focused on using clean, renewable energy, so we wanted to just figure out any sort of conservation stuff that we had with any conservation information that we didn't already have with golden eagles. So I guess one thing sort of led to another. So the grand total of my project became looking at the effects of translocation on the genetic population structure of golden eagles in North America. A little bit of an interest in historic populations as well, because we wanted a comparison. So I ended up looking at historic and contemporary birds, historic birds being museum specimens. But
Would you say that humans then had a pretty significant impact on golden eagle populations?
So actually what we ended up finding out more or less with goldens was, well, what my research seems to indicate is that there really hasn't been that much of a difference in the genetic structure of birds in the east versus the west. We had assumed that eastern birds were going to be this little isolated pocket, just since all information at the time seemed to indicate that eastern birds were reproductively isolated from their western counterparts. But there really wasn't that much of a genetic distinction between them. Now, bald eagles, on the other hand, is a whole different story potentially, but just because they had a strange reintroduction history as well. But with the goldens, we ended up finding out that they didn't seem to have that much genetic distinction between eastern and western birds even before the translocations. The translocations apparently didn't really upset that much.
Huh. That's interesting. Why do you think there's that difference between golden and bald eagles?
That was a question that kind of, I don't know, lingered towards the end of my dissertation. As far as the work that I've done so far, that's what the data seem to indicate. But I mean, in all respects, they're birds that have kind of similar life histories. You know, they're roughly the same size. Their diets don't exactly overlap, but they're both capable of long distance migration. They have similar lifespans. So I'm not 100% sure why I saw some, I guess it was more of like a clinal variation, like a clinal genetic variation in bald eagles, at least historically. But of course, modern bald eagles are all over the page because they're the result of so many different reintroductions, which was necessary to keep the species going, basically. But that was one thing that we didn't really quite understand. It could very well be that because my sample size for historic bald eagles was very small, I was using museum specimens, like preserved studies, extracting DNA from those as comparison. But yeah, we're not quite sure why there seems to be a difference there. Not 100% sure why golden eagles didn't look, why they seem to be so well, I guess homogenized to be a good word.
So you mentioned that they might be affected by wind turbines. Can you elaborate a little more on that?
Yeah, so one of the collaborators in my group, her research actually specifically focused on where are bald eagles flying as they come down like the Appalachian corridor. Did I say Appalachian or Alp? Yes, I said Appalachian. They're not coming down the Alps in the middle of North America. But one of our collaborators, her work looked at where golden eagles were flying during their migration pattern in respect to where were wind developers interested in putting up turbines. Because a lot of areas where it's just really good wind for putting up a wind farm happens to kind of overlap with some of the areas that golden eagles were using for migration. And golden eagles are sort of an umbrella species. So any sort of conservation efforts you put in place for them are probably going to impact a number of other migratory birds as well. So what one of our collaborators developed was she came up with a risk map. So she identified, based on a lot of weather data, she identified areas that had really good wind conditions for wind farms where eagles weren't necessarily traveling versus areas that had really good wind for wind farms that maybe eagles were using a little bit more. Because, I mean, obviously, everyone wants clean energy, but we want to make sure that we're doing it in the best possible way with wildlife. And I think it's a good direction. Find out where there's good wind hotspots, and then figure out where animals are going as well.
Yeah, because, we want to be doing the best for both that we can,
Mm-hmm. Yeah.
All right, and Dr. Brady Porter, your advisor at Duquesne, he mentioned that you might be offering some sort of lesson plan to the Audubon Society of Western PA's Eagle Cam. Can you elaborate a little bit more on what your plans for that might be?
Yeah, it's kind of a work in progress. So my advisor, he is on the, I believe it's an advisory board of some sort for the Western PA chapter of the Audubon Society. And, they have so many really great resources for teachers on their website. So things like videos that talk a little bit about bird biology, videos that talk about like bird nesting, just a lot of the conservation history of bald eagles. They have a really good assortment of resources for teachers and families and just anyone who's interested in bald eagles. So one of the things that Dr. Porter is wanting to set up, and obviously I want to help them out with it, is trying to maybe add in a little bit of some sort of lesson plan or maybe even videos on bald eagle or bird genetics. So that would just be a new avenue of resources available to teachers or folks just interested in learning a little bit more about bird genetics. We had thought maybe we could talk a little bit about some of my research with bald eagles, or even just some like general things about bird genetics that might be kind of interesting. It's just a couple minutes of a gee whiz factor in a classroom. Something like a couple lab techniques that just show how you can identify the sex of a bird using their different chromosomal arrangements. So like for humans, was it males are XY and females are XX? In birds, it's completely flipped. So females they have a Z and a W chromosome, and the males have a ZZ chromosome. And it's really easy to just amplify a little region of DNA and then run it out on a gel, and you can really quickly, easily visualize like a male versus female, male versus female specimens out on a gel. And that could be something that we could make a video of and have illustrations so that people can actually see how you visualize DNA results of some sort of PCR results. In a lot of ways, a lot of folks will watch something like CSI or NCIS, shows that I absolutely love, but the science may not always be there.
So that's really cool, though, that's sort of a connection between the general public and the scientific community that's open to anyone.
Mm-hmm. Yeah, they've done a really good job with that.
Do you find that being a conservation education specialist, that helps you kind of bridge the gap between the general public and the scientific community?
I do actually. I really love what I do at the zoo because it gives me a chance to try to connect folks back with nature, and in some ways connect folks back with science. Um, I hate to sound like an old person going, geez, there's so many kids today are just they're just so isolated from nature, and even just bringing like a black rat snake, something that is super common here in Pennsylvania, bringing a black rat snake into a classroom, students have no idea that this, could very well live in their backyard or, on their block, depending on where they live, of course. Not so much if they're living in more of an urban setting, but I love getting people to, see their own native wildlife, or even seeing something exotic. Just that moment of excitement where people have this brief little connection with nature. I hope that means, they take more of an interest in conservation and seeing that the planet's not just all about us.
Yeah, that's really the first step, right?
Mm-hmm. Yeah, and this year I've been really excited because I've designed a couple of programs that have been geared for older students and families that do help reinforce ideas like the scientific method and what's going on in the research world while still, still bring fun, cute animals in the classroom because that's where the good time is.
So if you were just if you have no experience in the science world and you wanted to get involved with this stuff, what would you recommend?
One of the things that I love about living in my city right now is I love that Pittsburgh, we have the zoo, we have the Natural History Museum, we have the Science Center, we have all these really great city resources that are just right here where you can volunteer. They have games and resources online. So learning is just all around, the potential for learning, which is really fun. So I would love for families to be able to do something like volunteering together or take a class together because I feel like learning, it works out really well when the whole family is involved. So me who was a nerd from the beginning, that's how I got into science as I started visiting the Science Center in Columbus, Ohio, where I grew up. That was also just a great resource for getting interested in how the world around you works. And it just kind of carried over from there. So I would definitely encourage folks to just take advantage of the resources that are around them in their own home city. So whether it's a museum or even the museum's websites, they often have really great resources that you can take advantage of when you're just trying to spice up your science curriculum or anything like that.